We're going to be starting with the next chapter, which is moles and stoichiometry. Okay, so these are like you can say branch of chemistry where you're doing a lot of quantitative analysis. That is a lot of measurements. Then samples are given to you if you want to check how much, in a given sample, how much carbon is present, or let's say how much a sample is there, how many molecules it has, or how many atoms it has. So a lot of calculated things is what this chapter will be dealing with. Now we will split before we actually take the whole core part of the chapter. We will do very basics today, where we need to understand what is the requirement for us to know before we take the questions. Okay, so very basic thing which you have done in a ninth grade, but I presume many of you must have either forgotten it or maybe is having difficulty in solving. So we'll be taking those questions today. Once you're very firm with it, then we will proceed to the next part. Now, coming to the first part of the chapter where we will focus more on the moles concept. Okay, so what is mole? Is it in unit or is it kind of measurement that we need to take? So yes, mole is a measurement when we consider some amount of substance. We have been given some amount of substance that is calculated in mole. Like for example, for us in mathematics, we know some terms like 1 quintal, okay, or 1 dozen, or when we use one pair, we know one pair means the number, the quantity is 2. Dozen it is 12. Quintal it is 1000 kg. Correct? So these are the units we are taking for, we're referring to some other unit and comparing it and putting it into that. So when the word dozen comes, you know that you are speaking for 12 number of some substance. Same way in chemistry, whatever amount of substance is given to you, it is usually taken in one mole. Now, it can also have half mole, it can have 3 moles, but that measurement is taken in moles. Okay. Now, 2, 3 things you need to do that will be used throughout this chapter. We'll come into the detailed part of it, but let's just understand the basics first. So, there will be a term called as Avogadro's number. Avogadro's number, and you just need to know this number's value very well. We represent this with capital N and capital A to the bottom, and this has a value. It is a constant number. It will not have any specific unit. You all need to take a note of this. It's 6.022 into 10 to the power 23. It's actually in trillions, so we cannot write so many zeros. So it's better we write it in the exponent form. So this is important. So in your board exams, they're not going to give you this value that you're going to refer and take the value as this. This will not be given to you wherever required, wherever you need to require to use this value or use Avogadro's number. This has to be done very well. Nobody is going to give you a hint in that. So this value you have to learn it. So write this down. It's the Avogadro's number. It's 6.022 into 10 to the power 23. The first part of your chapter demands for Yale-Lussac's law. Have you heard about this law before? That means in your ninth grade. Have you read about this person? Yes? Which chapter did you notice this law? This law is pertaining to volumes. Yale-Lussac's law is also called as laws of combining volumes. And very clearly, we are only going to discuss gases. All the concepts you will have and all the numericals you are having, you will only be doing the numericals pertaining to gases. Anytime you see a liquid, anytime you see a solid, you are not considering the volumes given for that. The solving will be only focusing for gases. Okay, so first thing is we have an order of this chapter. First part where we actually study some basics rules, and we're going to come to the first law, which is Gay-Lussac's law. Then we will do Avogadro's law, and then we actually come to the second part of the chapter, which is stoichiometry. Okay, so the first law that we are going to have, we'll quickly write a statement for it. Write the title, Gay-Lussac's law. Before we do that, can anyone tell me what is meant by STP and what is meant by NTP? Yes, it is standard temperature and pressure. STP, NTP will be constantly used. Okay, when you have the almost the second half of the chapter, it will be precisely written at STP, at NTP. So you should know what they mean. So write down the full form of both. STP is standard temperature and pressure. At that time, the temperature is taken at 273 Kelvin. Okay. Degree Celsius will also be there in a numerical, but every time we will make sure we'll convert. If all the things are in Kelvin and all the things are in a particular unit, then it's fine. But if there is a requirement of converting, we will have to convert degree Celsius into Kelvin, because Kelvin is the standard unit of temperature. So whenever we are taking standard unit of temperature, it is 273, and for pressure, standard unit will be 1 atm. And same thing you can use for other, that is mmHg. What is this unit? This is all something from your ninth grade. What is mmHg? Is millimeter. If you don't know, write it down. Millimeter of mercury. Okay. Any other units you all know? You can keep adding, but of course, the standard unit for temperature is Kelvin. What are the other units of temperature you know? Degree Celsius and
Fahrenheit.
Fahrenheit, correct. So these are the other units of temperature, but Kelvin will be the standard. Likewise, also tell me the other units of pressure. One I've given you at ATM, that is atmospheric pressure. I've given you mmHg. What is any other unit? If you know, you can tell me.
Centimeter Hg.
Okay, that's like the conversion part of it. Apart from that,
Tor.
okay, torsilly, and any other unit? Bar, BAR, barometric. BAR is also, and Pascal is also used. PA, Pascal is also used. So these are many units that you have. Be writing all the units pertaining to volume, because we do have the volume law here. So volumes unit is also important. Okay. So volume is taken with many units. You can write meter cube. You can write cc. Cc is used in a lot of questions. You can call this as cubic centimeter or centimeter cube. They mean the same. Okay, cc or centimeter with a cube, they both are the same thing. It's just the way of writing them. So centimeter with power 3 and cc means the same. Then you have meter cube. You also have decimeter cube. You also have liters. So these are the different units pertaining to volume. So write down the statement. It states that gases, or whenever gases, whenever the best example we can take is the formation of water. Okay, so when I want to form water, simply first you should know also to chemical balancing is very very important. If you don't know how to balance your equation, your answer, your whole chapter depends on that, because if you have not done the balancing correctly, the ratios you're going to pick down is going to go wrong, and eventually everything is going to go wrong. So you need to practice balancing of equation. You should know when certain things are combining, what is the expected result. So as and when we keep proceeding, we will get to know these things. You can first write down, whenever we are writing hydrogen, you should never write H. You should write that as H2. Oxygen also needs to be written as O2. Nitrogen, N2. Chlorine, F, just in case, I'm just adding at that, should be written with Cl2. Okay, so these are mostly the ones that are used. They are always in the diatomic form. So if I want to write hydrogen, just writing H is not the correct form. Hydrogen, whenever it is in the independent existence, it is in gaseous state and it is in a diatomic form. So I am going to take hydrogen. I have to take oxygen. So I write O2, and that's going to give me water, which is H2. At least you know the formula of water. Now to balance it, you need to keep, because oxygen is only one here, you have to put a 2 here in front and 2 here in front. Now whole thing is balanced. Now why this example is taken, because water here is not going to be formed in the form of liquid. Hydrogen and oxygen under very high temperature, they're going to react. And it is also an exothermic reaction. It is also going to give out a lot of heat when this happens. So under such high temperature, the water which is formed will not be liquid. It must have crossed 100 degree already. So the water that we're going to get here will be in the steam form. So hydrogen is gas, oxygen is gas, and the result is gas because it's coming out in the form of steam. So don't think we are considering liquid there. Formation of water, whenever this kind of example is given, you have to be very clear we're dealing with all gases. And as I already told you, we're only going to have questions we need to put up. And if just in case there is a liquid coming out anywhere, sometimes water is taken as liquid. It comes in the byproduct and it is in the liquid form. So you're not going to consider the values for water. We'll only focus on the gas part. Okay. Now, what does the gas law tells you? The Gay-Lussac's law that we have taken. What does it tells you is these are gases. These are your reacting gases. The left side ones, they are called as your reacting gases. And the product that you get, only pick up gas. Now here, luckily, you just have one product and that too, it is in the form of gas. So the product also has to be gas. And this is everything happening at a same temperature and pressure. So while it was reacting, you may fix up a temperature and pressure. And while you got a product, the temperature and pressure is constant, then only the law is valid. If there is any change in temperature and pressure, the law is not going to be turning out correct. So under constant temperature pressure, this is going to give you the correct result. Now, when you look into this, you just have to be very careful with the volumes. Now, what are volumes and from where are you going to pick up the volumes? Just like maths equations you have, only check the coefficient part. That means number that you see in front of any molecule or any particular element. Here the number is 2. Here there is no number in front of oxygen, so consider that as 1. Okay, and here the number that you see is 2. So this 2 is to 1, giving out 2. This is all whole number. You are not going to have any fraction. You're not going to have any decimals here. You will never get 2.5 hydrogen. No. You're not going to get 2 by 3 hydrogen. No fraction, no decimal will be there for your equation. You will get everything in whole number. And that is how you do your equation balancing. Whenever you balance the equation, chemical equation, you never take anything half or in decimal. You constantly, when you balance, you are taking whole number on either side. Correct? So that is what even the law tells you, that whenever gases are going to combine with each other, react with each other, they will give you product. Not necessarily the product will only be gas. There can also be some byproducts. But if you're only speaking for gases over here, the reactants are gas, and pick up the products which are gas, whenever they do that at a particular temperature and pressure without any change in that, they are always going to combine in volumes. And how are the volumes considered? Volumes are going to be whole number ratios. Okay. Here I've used this symbol. This symbol is for ratio symbol. So whenever they are related with each other, They are always going to be in ratio, and when you take that ratio, the numbers are going to be whole number. You're not going to get any fraction or decimal. And this is what that law tells you. Combining law for gases, it will only be in volume. So according to Gay-Lussac, he just tells that whenever gases wants to react with each other, mass is of course one part. It will be there. We'll take it later. But they always combine it by volumes. That's the first point. And secondly, in such a way that if you try to take the ratios of the volume, you will get ratios in simple whole number format. Oxygen and hydrogen will react to give you ammonia. And now we're going to balance it. First, always write your rough idea. If you know your products very well, then you can pick up, okay, nitrogen was used and hydrogen was used, you can take them. Nitrogen is in the form of gas, hydrogen obviously is in the form of gas, and ammonia result is gas because it's an exothermic reaction. A lot of heat is given out. This is always, see, maybe in Haber's process, eventually we may collect it in liquid form after condensing the gas. But the first form that you're going to get is in the vapor form. So ammonia is obtained in gas form. Later in industry, you can condense it and get it into the liquid form. That's the later part of it. But in the first process, you get it in the gas form. Now tell me how you're going to balance it. Nitrogen is 2 on the left side and it's only 1 on the right side. Hydrogen is 3 on the right side and 2 on the left side. So what should you do to balance it?
Ma'am, we can put 2 in front of NH3.
Okay, I'll put that here. All the
And
extra
then
number. Hmm.
3 in
So now
front of
nitrogen
H2.
is 2, 3. Correct. So this is your balanced equation. Everything is in the form of gas. Now let us learn how to write the ratios. What is the ratio of N2, the first one? For N2.
Uh,
There is no
N2.
number to the left of it. So it is
Okay,
1.
one.
H2 has 3.
6. Oh, sorry,
No,
3, 3,
don't add it. Just the number in front of it.
Yeah.
3,
Okay.
3,
And then this is 1 is to
3,
3. And yes. And here what is the number? Number in
2.
front. Yes, it's going to be 2. Okay. Arrow mark or colon. So the ratios you see is 1 is to 3 is to 2. So write this down as an example. I have carbon monoxide given. Okay, write down. I'm also giving the highlighting point. It's not there in your textbooks though, but at least you can write it so that you know whenever in exams they give you this has been formed and that has been changed, then you know what you have to pick up. So formation of carbon dioxide from carbon monoxide. They can give it in this way. They can give you words also. Word equation is also a lot used in this chapter. Carbon dioxide from carbon monoxide. Okay, it's a very simple equation. Carbon monoxide, you know, it is CO. It's a gas, but it's a poisonous gas. Now the question is why we have to convert it into CO2. The problem is whenever any industries, maybe they are, you know, they're focusing on producing something else. But if CO, carbon monoxide, is one of the byproducts, it comes under the many byproduct, extra products. Even if it is in less amount, this is a very harmful poisonous gas. So they cannot let it out directly into the atmosphere. So by the Pollution Control Board, you have to convert the CO into some suitable, safer compound. So the best, safest thing is convert the CO into carbon dioxide, which is cheaper because oxygen is anyway used for oxidation, for combustion. Oxygen is abundantly used in a lot of industry. So what you have to do, what they have to do is they will take up carbon monoxide and they will combust it, or let's say oxidize it. And oxidation happens in the presence of oxygen only. Whenever, now get used to these terms, I'm also giving you keywords. Whenever combustion word is used, okay, or oxidized, this term is used in your questions. That means there is always an involvement of oxygen. It may not be given to you, but you should know combustion means, of course, you know, combustion, for that it needs oxygen. So anything is getting burnt, or even sometimes they use the word burning. It has been burnt at this temperature. or this much sample has been taken. So burning, oxidize or combustion, these words are used. You will always have O2 in that reaction. So whenever you have to convert carbon monoxide into carbon dioxide, you're oxidizing it. You're going to burn it in the presence of oxygen. So oxygen means you will have to write O2. Don't write O, write O2. Oxygen is gas, carbon monoxide is gas. And you will get CO2. That is what you want. But see, is it balanced or not? CO2 is also a gas. Is it balanced?
Ma'am, you put 2 in front of CO and 2 in front of CO2.
2 in front of CO and
Uh, and 2
2
in
in
front of
front
CO2.
of CO2. Okay, 1, 2, 3, 4. Yes, that is correct. Now this is balanced. Okay, gas is right for all. If there is something, I'm just saying extra A, which is a liquid, don't use ratios for that. If it's a liquid, don't write it. Sometimes there are byproducts, can be liquid or solid, anything, don't write for that. Okay, only 2 is to 1 is to 2. Nitric oxide, formation of nitric oxide from nitrogen. So think about it. You should know the formulas for that. So nitric oxide, what's the formula of nitric oxide? It is NO. See, NO2 is, if you are very confused with a lot of compounds name, you can quickly write this down. NO2 is nitrogen dioxide. Okay. NO, single N, single O, it is nitric oxide. And if it is N2O, okay, see where the 2 is written. It is N2O. It is called as nitrous oxide. Okay. So what we want to form? We want to form nitric oxide. So that is NO. Of course, it is a gas. So what are the things you need to have in the reactor? You can always use the reverse method. If you know the product very well and the direct combinations also, you can go in a reverse way. So N and oxygen, nitrogen and oxygen. As I told you, N can't be written single, you have to write 2, oxygen also 2. Both are gas. Okay, see it is balanced or not?
Ma'am, we need to add a 2 in front
Yes,
of NO.
correct. Just put 2, then nitrogen is also 2 and oxygen is also 2. It's balanced. Now tell me the ratio.
1 is to 1 is to 2.
Correct. The ratio is 1 is to 1 is to 2. Okay. So that is what you gave LUSSAC. This is not the only question. We need to solve that. The first thing is you should know to write the equation, balanced one. And secondly, to pick out the ratios. Once you are very clear with the ratios, half of your work is done. Okay. Organic chemistry has the last chapter, but a few equations from that is taken here. But how you're going to remember everything? Put a star mark and write any time a hydrocarbon is used. What is it? Hydrocarbon. How do you identify hydrocarbon? You just have C and H in various ratios. The rules and all that we do in the organic chemistry chapter, but right now I can just help you with this because we do have hydrocarbon getting under combustion. So whenever you have compounds of C and H, like CH4, it's methane. We have ethane, we have propane, like that. We do have some compound. They are categorized as hydrocarbon, and the way to recognize them is they are just going to have C and H in the formula. But of course, the numbers may be different. It might be C2H6 or something. Numbers may be different, but yes, we will only have C and H in the combination. And instead of hydrocarbon, they can also give you in the question, it's a um, natural gas, or they can also use it is it's a greenhouse gas. They can also use this term, greenhouse gas. Okay, so the example, this example I'm giving you, it's a hydrocarbon as well as it's a natural gas and it's a greenhouse gas. This example they're telling you is for methane. Methane is one of the greenhouse gas and it's a natural gas. So methane, remember, this is that example of greenhouse or natural gas. And you can also consider that as the hydrocarbon. So anytime you have some other combination, like they give you C2H2, it is ethene. If they give you this, So whenever you have C and H, as you look into the question, then you know you are actually doing the hydrocarbon. Now, how will you know what to write in the equation? Anytime they will only give you combustion process. Whenever from mole concept, when you have questions of hydrocarbon, they give you only combustion. So combustion, what's the first thing that should come to your mind? Whenever you are doing combustion, oxygen will be involved in that. Balancing part that we can do later. But first you should know what are the reactants. So if suppose I have methane, I've picked up methane and they have given us burning or combustion of it. So I will write O2. That's for sure because burning combustion will always have oxygen. Methane is a gas, oxygen is a gas. Now we have to think about the product. Now, product for any hydrocarbon that goes through combustion, you pick up any hydrocarbon, it is C2H4, you can take CH4, any hydrocarbon given, propane, ethane, anything, butane given to you. Combustion will only give you two results for sure, and you can highlight that. And there's always going to be carbon dioxide and water. Carbon dioxide and water with a lot of heat. So, in most of the cases, water will be used in the form of steam. That means it will come out in the form of steam. Okay, and CO2, of course, it's a gas. Always, this is a fixed result. So you don't have to worry whenever hydrocarbon is given to you, and combustion is only the question they will put into that. So combustion will have oxygen for sure. And what is the result you need to write? You will always write carbon dioxide, which is gas, and water. Now, sometimes, yes, there is a tricky thing they put into hydrocarbon combustion. They give you temperature. Suppose they give you temperature is 80 degrees Celsius. Okay, they tell you that okay, this whole reaction happened. Sometimes it's complete combustion. That means all the methane I had got all vanished up, all utilized and come has gone through oxidation. But when they give you temperature restriction, 80 degrees Celsius, I know H2O is going to be there as a result. But at 80-degree temperature, H2O, what is the physical state of it?
Liquid.
Yes, it will be in the liquid state. Even though it is very warm, this is a very hot water, but it is in the liquid state. So at that time, when you're writing the equation, you will change G and write L. Okay. Sometimes they do give you that condition, like it has been, burnt at 250 degrees Celsius. 250, of course. Anything that cross 100 degree means H2O will be in the gaseous state. That time you will pick up gas, the ratio for gas. But if the ratio for water. But if it is less than 100, like 70, 80, 90 also they're giving, that means it is less than 100, that time water is formed, but it is in the liquid state. And during that time, whenever you want to find the ratio, you will not write the ratio for H2O. Okay, now let's do the balancing of it. First, take a note of all the content I've given. Then is CH4. Okay, we are going to burn it. So oxygen, and it will give results of it CO2 and H2. Right now, I'm considering water coming out in the form of gas. This is also gas. Oxygen is gas and methane is also gas. First, check if it is balanced or not. Carbon is 1 and 1.
It's not
Hydrogen
balanced.
is 4. So
You have to do two H2O and two O2, I think.
yes, we'll put a 2 here. So hydrogen gets balanced. And 1, 2, 3, 4. So 2 over here. Yes, 2 over 2. Now it is balanced. Okay. Correct. It's going to be 1 is to 2 is to 1 is to 2. Okay. So everyone can take a note of this. Try one more, that is hydrocarbon. One more hydrocarbon. It is C2H4. It is ethene, which is being burned. So burning means O2, and you know the result is fixed. It's a hydrocarbon, so it's always going to give you CO2 and water. Okay, once you know this is the thing you need to do later, then you can know how to balance it. First, always balance. If your balancing is not right, you will not be able to pick up the correct ratio.
In front of oxygen.
1, 2, 3. Okay, 3 here. Then
2 in front
oxygen
of
becomes 6.
H2O.
Okay, 1, 2, 3, 4. And
And then 2 in front of CO2.
yes, that is right. So you have this gas, 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 and water is also gas.
1 is to 3 is to 2 is to 2.
Correct. 1:3:2:2. 20 ml of, let's say, now the question is, you might think it's a gas and then how you're taking the units in milliliter or liter. Yes, you can take the gases volume in liter, milliliter, decimeter cube, centimeter cube. Okay, these units are all acceptable for gases. You can use the liquids units precisely even for gases. Or top one, which is N2 plus O2 giving nitric oxide. What is the ratio? 1:1:2. Now, if I will tell you that in a question I have that oxygen is 200 ml. So guess how much is the like total reaction happen? It's not like sometimes there are incomplete combustion that will take place, but in this question, it's a complete combustion that took place. So you have to tell how much nitric oxide was formed, how much nitrogen was there. So how much nitrogen is there? Now how you want to think is 1. So 1 volume is representing 200 ml in your sample. So 1 volume, wherever you find the number 1, that is representing 200. That means nitrogen over here is 1. So how much volume of nitrogen was used in the reaction? 200 ml. But how much is NO, that is nitric oxide? It is 2 in the ratio. 1 volume is 200 ml. So tell me 2 volume will be how much? 1 volume is 200 ml. Correct. It's going to be 400. So how much nitric oxide will be produced? 400 ml. So if you know your ratios very well and one part is given to you, you will be able to find out the remaining. Okay. Let's try for this one. And that would be the, if you want, you can take a note of the nitric oxide and then we come to the ethene part. Writing on the top, 1:2, 3:2, 2:2. Okay, complete combustion. Ethene, no, not ethene, CO2. CO2 sample, I have 500 ml. Okay, so whatever is being produced here, it is 500 ml. So you have to tell how much oxygen, how much ethene, and how much water vapor is produced. So what sample is given to you? CO2 sample, and CO2 is representing the number 2. Okay, the ratio is 2. So 2 means what? 500 ml. So 2 volumes means 500 ml. So you should always take 1 volume from that. 1 volume will be how? 50. Okay, now you know the value of 1 volume. 1 volume is 250 ml. How much ethane is used? Correct. 250 ml ethene is used. Okay.
750.
Correct. 750. That is right. Oh, this is already there. That is 2 of them. That is total 500 as per the sample. And correct. That's going to be 500 ml. Okay. So clear about this. So there are 3 steps. You should know the reaction. Second, balance it. Then take out the ratios. Whole number you're going to get. So whole number is mostly the best thing that is workable here because you don't have to work with fractions and decimal. And anytime one particular sample is given, okay, from that you can take out 1 volume and you can find how many the rest of them were produced or how many were used. So this was very straight question. We do have limiting reagents questions also. So those we will start working with tomorrow. So today